I did a very stupid thing.
No way. You did the recording, but didn't start the
Yeah.
mic. We can start over.
Not a chance because they muted the room's mix. Yeah, I have speaker notes and they will be, I'll publish the presentation and they will be available. So yeah. Thank you, Sorin, for mentioning it now. Okay, I have somebody joining remotely and yeah. Okay. That would make for a good drinking game. But I started the make when the story gets interesting. So we've seen where we're here now, but let's talk a little bit about ancient history. So in the beginning, life was rather simple. As I said, the system had custom UIs, but they all did pretty much the same thing with just different look and feels. The test framework was written in Java 1.4. Mind you, even at the time, we were slightly outdated. Java 1.5 was rolling out, but we were still holding strong to Java 1.4. And we had like 1,400 tests in 150 test classes. It might look like much, but it's not that much. It was actually manageable. People didn't even write test plans because they put the test plans inside the test classes. And at the moment, it looked like a good idea. Turns out it wasn't necessarily a good idea. And everything ran on a manually configured local machine. Basically, it was a desktop under a developer's desk. And if something didn't work, you would basically either have to ask the developer to take a look or crawl under his desk and plug in a keyboard and a mouse and a monitor or use SSH if you felt adventurous. Yeah. However, there were some really smart people on the team, and they did some really nifty tricks with TestNG in order to exercise the same flows on the different UIs, but writing the test logic just once. So everything was okay, and because there were very few people contributing code, and it was still easy to deploy the whole shebang on your local machine while developing, we only ran the tests after merging the code. So basically, you would write the test, you would write the code, you would write the test them on your local machine. That wasn't that different from the CI machine. When you're confident, you would merge, and then that would start a run on the CI environment. And it worked like that for a while. But then that particular machine died. And you might have figured it by now, but yeah, we had source control was in place, but the actual setup of the machine was really tedious because you had to set up the machine for running the product, but you also have to set it up to run the actual tests, and it was something that took days to set it up. And okay, we thought to ourselves, okay, shit, did happen. We'll have to do it again, obviously. But what can we do to avoid having to spend another day when a machine decides to die? At that moment, the rather obvious answer was, okay, we'll use virtual machines. And where we previously had this server that was managed by us, we actually got to use a real server that was managed by the local IT tech support team, a real server with copious amounts of RAM, numerous cores, so it was good. And we thought about, okay, we have more hardware, let's do something with it. So we decided to add more slaves. We added separate slaves for building the code and running the tests. We even added a new environment for running code coverage. It was something that took, I think, half a day. Yeah, the instrumented code was slow. Running the test again, that environment was slow, but we got 70-something% code coverage, which was pretty good at the time. Once we started having those slaves in place, we thought, okay, maybe it would be a good idea to validate the code before merging it. And so we implemented feature branch validation. Sorry. Yeah, it wasn't perfect. It wasn't all magic fairy dust. But it worked a lot better. You could now reboot the machine without having to crawl under the desk. You had nice performance graphs courtesy of the VMware hypervisor, so it was nice. But then somebody decided, you know what? All those demo labs in each office, they're kind of a waste of power and money and space. And yeah, we'll consolidate them, and then we'll have Adobe have its own platform as a service and infrastructure as a service, which I think was an interesting project for somebody to build their own toy AWS inside Adobe. But for us, it meant that we could no longer just go to our manager and say, hey, we need another 60 gigs of RAM. Give us some money so that we can go and plug some RAM in the server. Because now that server wasn't there anymore, as the VM infrastructure got consolidated. So long story short, we got a hard deadline by which we had to move all of our test infrastructure out of those servers. Nobody said where. However, the thing is, by that point, the actual IMS environments, the production ones, moved out of the data center and into the cloud. And we said, okay, the tests were getting slower anyway. We could put more RAM into the machine, but actually putting more cores was hard. So yeah, maybe we'll move to the cloud as well. And another thing that convinced us to move to the cloud was that in the existing setup that was now being decommissioned, there were bugs slipping in. And this was happening not because, I mean, yeah, they were happening because we didn't think about them. But they were also happening because there was this big discrepancy between what was really deployed in production and what we were using as CI. As I said, we were still running the server and the test on the same machine. The server was running over HTTP, over a non-standard port, and it was all running on the same domain. The production servers are actually split onto domains with different endpoints being on different domains. And that means things like cookies and sessions and people being logged out when they shouldn't be logged out and stuff like that. So because bugs were slipping in, we said, okay, you know what? Let's move everything to the cloud. The cloud will solve all of our problems. Not. Yeah, so we said, okay, we already have the infrastructure in place to raise environments in the cloud. We were using that for production and staging. We said, okay, let's use it for our CI environments as well. That went out rather well. And then we said, okay, let's use cloud-based slaves as well. You could basically pay Amazon and get a machine however powerful your money could buy. And at that point, you also had a white check, or I think it's carte blanche. Basically, people said, you know what, move to the cloud and don't mind the costs. They're covered. It's okay. And I said, oh, okay, so we can now move from our server to, oh, they have this nice 8-core, 32 gigs of RAM machine. Wow, we could use that as a slave. And it looked like a good idea, right? Run the test on these big, powerful machines. Well, that was nice. Getting there was a little more complicated because, you see, source code is not allowed to leave the premises. I think it makes sense why. And the premises, you know, they're kind of invisible to the outside world. So the Jenkins master that we set up in AWS couldn't see the Jenkins master that was inside the intranet and building the code and producing all the artifacts. And we kind of tried and pleaded our way with various ops people, IT people, VPs of IT and whatnot. But turns out that getting yourself a tunnel from the intranet to AWS is complicated. And basically the answer was, it ain't gonna happen. So what we did was something that's not on these slides. What we did was we had these two Jenkins, one in the intranet, one in the cloud. And we set up a shared storage on Amazon S3 bucket. Just a second. Sorry about that. Yeah. So we set up a shared storage. Basically, the build Jenkins was putting the artifacts in the bucket, and then the test Jenkins were reading them from there. Since the build Jenkins could see the Jenkins master in the cloud, it could start jobs there, and then it would keep polling, saying, okay, are the tests done yet? Are the tests done yet? And after a while, you would have your test results. So we made it work in the end. So the problem is that the entire architecture of the solution was a little bit ahead of its time. So for instance, the Jenkins slaves were using Docker in order to configure the software stack on the machine and run the actual test. So there was an additional layer of indirection. And also the slaves were statically manually configured in the master. Basically, somebody went in the master and said, okay, I want these slaves. And the IPs were set up and the Jenkins agent was manually started. And yeah, it kind of worked. We now had, I think, 10 or 12 Jenkins slaves that were those really powerful machines, 8 cores, 32 gigs of RAM. So yeah, at that moment, running this worked. But as we kept adding more and more features, you also had to keep adding more tests for those features. And when we started the migration to the cloud, basically all our tests were split in just 2 suites. And we were running one suite on one machine, one suite on another machine, and that was it. But as we kept adding more and more tests, the test run started increasing. I think at one point we hit, I think, 30 minutes per test run, but after the entire environment was in place. So basically, if you wanted to validate your code, you could very well take a 1-hour break or start working on something else, which was not necessarily conducive to being very productive. So we said, okay, let's see how we can try to scale horizontally a little bit better. We initially tried to scale vertically. Amazon just launched a new tier of more powerful machines and said, okay, 16 cores and 64 gigs of RAM should do the trick. It didn't. Because at one point, neither CPU nor RAM was the actual bottleneck, but actually the I/O to the disk. When you're trying to raise hundreds of instances of Firefox, I think 15 or 20 at that moment was rather slow. When you're doing a lot of network I/O against a machine that isn't necessarily as powerful as the slave your tests are running on. Just throwing more processing power on the same machine doesn't do the trick. So we thought, okay, let's split the tests more granularly so that we can spread them across more machines, not just two. And we did that. We basically went through the tests manually and we split them in, I think, 5 or 6 or 7 test suites. And we tried to balance the runtimes for those suites. At the same time, some, again, smart people in the team did some really nice optimizations to the build and deployment process so that you can start the build and deployment. And by the time the tests are compiled, you would also have a lot less to wait until the environment was up and running and you could fire the tests at it. So, yeah, and somewhere in 2016, we were able to get the runtime of a full suite run down to 12 minutes. Including the deployment of the environment, this was really, really good. You would just go out and have a smoke and come back. You would have a coffee break anyway. You wouldn't have to wait 1 hour to get test results back. But then people started looking at the costs. As I said, we were throwing really powerful machines at the problem, and having the slaves manually configured and statically configured meant you didn't have an easy way to turn those slaves off when you didn't need them. Basically, there were 12 really powerful machines up 24/7, and most of the time sitting idly because you wouldn't run tests 24/7. So we started investigating what we could do better. And at that point, we realized that we had another problem that we were kind of sidestepping or always brushing under the rug. The fact that upgrading the slaves was hard anyway. You wouldn't have to SSH on 10 individual machines. You didn't have to crawl under a desk to update the Firefox version on the machines. But you still had to change a Docker file, commit the changes to the Docker file, make a build, and then SSH to the machines and sync the slave. And that was the happy case when you knew exactly what needed to be done. If you had to do this back and forth, it was really, really tedious. I remember we kept postponing upgrading the Firefox version, I think 3 or 6 months, because it was 2 or 3 days of really, really, really boring and ungrateful work to do. And at that point, with the help from an ops guy, we moved away from the existing Docker-based solution to having slaves be spun up and down on demand using an auto-scaling group. Basically, an auto-scaling group is something that you says, okay, this is the image that you have to use for the machines, and I want to have X number of machines. You could tell the auto-scaling group, I want to have 3 machines, and it will raise 3 machines, or it will kill 2 machines if it had 5. And that allowed us to basically start a build, start building the code, start building the tests, and at the same time raising up the machines. And by the time the server was deployed and the tests were compiled, you already had the Jenkins slaves up. They were registered with the master, and you could start running tests on them. If you wanted to run just 1 test suite, you would get 1 slave up. If you wanted to run 12 test suites, we would raise 12 slaves. Also, this came with 2 major benefits. One is that just having to specify an image made it really simple to change things. You would raise a machine on your own based on that image, make whatever changes you wanted there. save that machine as an image, and just tell the autoscaling group, okay, use that image instead of the old one. And that was it. And then when it was raising the new machines, it would use the new ones. And there was another benefit that I forgot about. Yeah, cost. You now didn't have slaves sitting idly, which is a good thing for the planet. However, another thing that started happening at the time was that a lot of complexity was coming in terms of features in the product. We started integrating with more and more external services, services like Facebook and Google, and a federation provider, SMS providers. And as I previously mentioned, having all those systems when running integration tests can lead to slow tests and flaky tests. It leads to flaky tests because maybe Facebook decides it won't work, or they decide to change the UI. Or maybe the SMS provider says it sent the email, but it didn't send the email. And some services were just slow. Facebook. They're developer friendly, but they're slow. So we started investing in creating those mocks that I previously spoke about. For the people that didn't have audio at the time, we mocked Google, we mocked an SMS service provider. What else did we mock? And the mail server, yeah.
How did you tackle the changes on the actual applications in the mocking service? Meaning that Facebook will change their API if you need to update the mocking system as well?
If that happens, yeah. But basically, when everybody publishes an API, they do their best to either keep it consistent, so not to break it, or, as is the case with Facebook, they usually give a heads up at least a couple of months in advance saying, okay, we're deprecating this API, or this API will not keep working the same as it did. But again, Facebook are rather developer friendly, and we didn't mock them. We might have to do something else about them, but that's for another time. And this allowed us to have more confidence, basically, in our tests. The test suites were still large. Running all the tests still took a lot of time. Right now, running a full test takes about 30 to 40 minutes, including the time it takes to deploy the environment, right? Build and deploy the environment. But we're now boldly going where I, at least personally, didn't hope we'd get before 2020 at least. And we're working on some really, really cool stuff. As I said, we're rolling out a new version of the UI that had the big advantage of being started from scratch. And this allowed us to advocate for a more testable architecture. And we were actually able to implement it. Just to give you an idea, so in the old IMS, what we worked on for the last 4 or 5 years, we had something like 85% of the tests were these big end-to-end integration tests. And 50%, and I think 50% is a very generous number, for unit tests and functional tests. Basically, either class level tests or controller level tests, stuff like that. Now we moved to a situation where the ratio is kind of reversed. We have, I think, less than 100 end-to-end integration tests for the new system. But we have something like 4,000 or 5,000 tests that are either unit or functional. Because we now have a decoupled architecture that can be tested in isolation. And yeah, there's a lot of really nice things that happened there and that proved that you can actually benefit on the development side as well if you architect testability from the get-go in the application. Again, as I previously mentioned, we moved to having the performance test as code. It's Scala code in its own Git repo. And now we're in the process of actually providing some shared libraries so that people don't have to reinvent the wheel. And one of the things that we're working on as we speak is not having a fixed set of CI environments. Basically, whenever you say, okay, I want to validate my pull request, a brand new CI environment will be raised just for you, and the tests will run on dedicated slaves against just that test. Because what happens right now is that we have two CI environments for feature branch validation, and when there's 5 or 7 people that want to merge their pull requests, there will be a queue of 4 or 5 tests that just wait for the other tests to complete so that they can run. And having on-demand CI environments will basically eliminate this problem of waiting in the queue. And another really, really cool stuff that we're working on is rolling out our brand new in-house test runner based on TestNG that will allow us to scale horizontally even more the test load. Okay, so this was the story from the time of the dinosaurs to the present day. What did we learn apart from those 3 key takeaways that I've listed at the beginning? Well, there were some hard to learn lessons, but there were some good as well. One of the rather interesting learnings was that actually deleting code is a lot harder than you would imagine, and sometimes even harder than putting new code in. There are people in the room that work on deprecating some features for like 2 months, 3 months, 1 year. Yeah, so features that took like, okay, maybe a couple of weeks to 1 month to be implemented. We're now trying to deprecate them, and it took us months to deprecate it, and we didn't yet didn't go there yet. Okay. Another interesting learning was that scaling out can solve problems, but it also has this very interesting side effect where it exposes the critical path. What we learned while building our in-house test runner is that it's really nice when you can basically run one test on one machine, but it won't help you get the runtime of the entire suite to 1 minute if you have one single test that takes 20 minutes to run. And it's interesting because up to this point, nobody actually quite cared about the performance of the tests they were writing. They were concerned about the performance of the code they were putting in the product. But very few people cared and actually actively tried to improve the performance of the tests they were writing. And that's why test performance profiling matters. And again, here there's a lot of things that can be done to improve that. But an important thing to note here is that there comes a point when you really have to understand how your test runner is working, how threads are used in your test runner, what blocks what, and what parts of the tests are running in parallel or what don't. I wasted, I think, 4 weeks of work because I didn't understand how Spring worked in the context of initializing some of its internal state that we were using in the test framework. So at one point, you'll have to deep dive into the actual code of the test framework that you're using. as I said, setups and teardowns can prove to be a bottleneck. And yeah, know thy framework. There were some good things coming out of this. And although it might not sound like, it really turns out that when you get other people, when you share responsibility with others, more things will happen when, rather than when some things are just your own responsibility. Back 2 or 3 or 4 years ago, the test framework itself and the tests that were written were the sole responsibility of the tester in the team. But as time went on and developers started writing their own tests because they wanted to get a feel of whether their feature is working or not, they started feeling the pain points that we as testers in the team have complained about for a long time, but nobody would listen to us because managers were paying to see features in the product, not improvements to the testing framework. But when the developers themselves started being hindered by the problems in the test framework, things started moving forward because we started working together. And as I said, on new products, we were able to build and to bake testability deep into the architecture. On the existing products, we were able to do some refactoring and work with people throughout the team to radically improve the testing framework. Also, the testing pyramid is real. Don't write all your tests at integration level tests. That's what happened with us. And it's really ugly to have 10,000 end-to-end integration tests. They're slow, they're brittle, and you have very little confidence in them.
You don't know if something breaks, where is the fault?
And that as well, yeah. And there's a lot of edge cases that you really can't hit using those, and that you could actually hit if you're testing at a lower level. Also, don't be afraid to dream. As I said, we're working on some stuff that I really wouldn't have hoped we would get to work on. But while you're dreaming, do advocate for extra testability, whatever it is that you're doing. Because testability might be just a buzzword, but unless and until you actually go in and say, okay, we need these changes and these changes and these changes in order to be able to test the thing, testability won't come out of thin air. So the fact that for the new UI we have an architecture that's testable is that we directly influenced some architectural decision in there. And when you do hit the limitations of whatever solution it is that you're using, don't be afraid to roll your own. However, do be sure that you really squeezed out every little last bit of performance out of what you're using. For us, the decision to roll our own test runner was not an easy one. I think it was the good one. We'll see in maybe a couple of months, but it was not an easily taken decision. Yeah, I think that was it. If you have any more questions that you would like to have as a whole, I have a mic here so that they're recorded as well. Otherwise, we can. I can take questions in private. So yeah, thank you.